Hi guys, I just want to make sure that the sound is good. We're going to learn about solving quadratics today. I'm very excited because I love polynomial functions, and so this is sort of the precursor to polynomials. And we're going to see polynomials too, and you're like, what the heck is that? And I like roller coasters. So polynomial functions are like roller coasters. All right, let's get started. We are going to take notes today. So the title is How to Solve Functions by Factoring Quadratic Formula. And the first thing you're going to write down is when the function is in standard form, as you see right here, okay, write this function example. When it's in standard form, the first thing we're going to identify is that this number here, is that this number here is the y-intercept. And I'm going to just connect everything to the graph that we see. I don't know why this is super weird. It usually writes pretty smoothly. But you can see right there that the y-intercept is -4 and the y-intercept is -4. So that's the first important thing that we know. The next thing we're going to identify is the roots. So you probably remember those from previous years, and the roots are where the graph crosses the y-axis. So on here is one root, and here is the other root. So they're really easy to see in the graph at -1 and 4. Now let's go over how we find it from the equation, because that's what you're going to be doing. So we're going to take what you learned last time, the factoring, and just do one more thing with it. So here we're going to factor this. Okay, so I like to use my diamond. It multiplies to -4, it adds to -3, and when I think about that, it's -4 and +1. So I write it, and oh, the important first thing I forgot is you're finding on the x-axis, and the x-axis is always where the y is equal to 0. So we're going to replace the y with 0. So I write 0 equals x squared minus 3x minus 4. And then I factor 0 equals parenthesis x minus 4 x plus 1. And let me see if I can... Yeah, make that a little bit smaller. Okay, perfect. All right, so the next thing we're going to do here is we're going to do what I call the split and solve. So if you've ever seen Legally Blonde, you know the bend and snap. And so I call it the split and solve. And so we're going to be splitting and solving anytime we have factors. So if we have an equal sign and factors, this is what we do next. We split it where the factors meet, and we set each one equal to 0. X minus 4 equals 0, x plus 1 equals 0, and then you just solve each one, right? So here you add 4 to both sides. So x is equal to +4, and here you minus 1. This was a 0. And x is equal to -1. Notice that matches. -1, +4. So pause it, take notes. We're going to do a couple of these. Okay, so here I'm just going to show you it's already factored. Okay, so I'm going to erase everything. It's already factored. So I just do my split and solve. So I split. So it's all the parentheses. Okay, here there's no variable, so I don't have to do anything. Here I write x plus 2 equals 0. X, sorry, it's kind of small, minus 4 equals 0. 0. And x minus 8 equals 0. So you minus 2 on both sides, and x is equal to -2. Add 4 on both sides, x equals +4. Add 8 on both sides, and x is equal to +8. Notice the matchup. -2, +4, and +8. And here's that roller coaster I was telling you about. This is a polynomial function. So now we're going to combine what we did last time, the factoring, and what we're doing now, finding the roots. Okay, so here's the next example. Okay, so here it's in factored form already. Okay, so I'm going to split and solve everywhere that I see it. Okay. And we're going to do the exact same thing. This one's just slightly different. I would definitely write this example down. And so I'm going to make this a little bit smaller. Okay. So here I have a variable, so I'm going to write x equals 0. Here I write x minus 3 equals 0. And here I write x plus 5 equals 0. Here I don't have to do anything, so x is equal to 0. That one's done. I add 3 to both sides, x is equal to positive 3. I minus 5 on both sides, just to show you one example, and x is equal to negative 5. Those are my 3 roots. So notice this first one, this number in front, matters because that's going to be right here. That's at 0. So it does cross at that point. So all of these numbers I'm finding are the roots where the graph crosses the x-axis. All right, let's look at another one. Okay, so here, maybe I'll make a different color. All right, nice magenta. And we are going to do the same concept, but now we're going to factor. Notice that I have a GCF. All of these have an x, and all of them can be divided by 3. So my GCF is 3x. So 3x. Remember that I'm replacing the y with 0 because I'm finding where does it cross on the x-axis. So now I have 0 equals, the 3x goes outside parentheses. Some of you guys might have been using an app to cheat on this. Please don't do that because you need to know this and you are going to have a test in class on this. So it's so important that you take the time to write it out. You'd have to divide each of these by 3x. So here when I divide that, I get 1x squared, or I can just write x squared. Here I divide this and I get negative 8, and there's an x left over. And here I divide that and I get positive 7, and the x's would cancel out and I wouldn't have any x there. Now I'm going to factor what's in the parentheses here. So what multiplies to 7 and adds up to negative 8? Well, if it multiplies to a positive, they're either both positive or both negative. So this tells me they're both negative. And what multiplies to 7 is 7 and 1. And negative 7 plus negative 1, is negative 8. So I write that x minus 7, x minus 1. I bring down the 3x in front, and I write equals 0. Okay? Now I split and solve. Okay? So you're going to, I'm going to make myself a little bit smaller, set each one equal to 0. 3x equals 0. X minus 7 equals 0. X minus 1 equals 0. Okay. I divide by 3 here because you have to get x alone. So x is equal to 0 because 0 divided by 3. I add 7. I'm just writing it all out. Pause the video and write this all. X equals 7. I add 1. And x equals 1. And if we match that up, it's crossing at 0, at 1, and at 7. So we can always check by typing it into the function and seeing, does it cross the x-axis at the numbers I'm getting? These are going to be the solutions. So in Delta Math, there's going to be a little plus sign on the side. You may have to click that to show that you have more than one answer. Okay, you have more than one root. In this case, we have 3 roots because it crosses 3 times. Okay, we're going to do 2 more just to make sure you understand this. Make sure you're pausing the video at each part and taking notes on that. So here, this is the factor by grouping because we have 4 terms, and hopefully you remember this from last time. This was the new type of factoring that you probably hadn't seen before. So we're going to factor it by grouping. We replace the y with a 0, and so we end up with 0 equals, okay, here the common thing that divides out is x squared because only a 1 would divide out of both of those. So when I divide that, I get x, divide this by x squared, and I'm left with 4. Here, whatever sign this is the sign that I'm going to use, and 9 can divide out of both of those. So 9 goes there. Divide negative 9x by negative 9, and you have positive x. Negative 36 divided by negative 9, and you get positive 4. Remember to write, if they are the same, you write same, 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 same. I love it when it's the same, same. And then I have x squared minus 9. That goes in one parentheses because those are the two that are outside here. Okay, so those two. Okay, that goes right here. And then the x plus 4, which was the same, goes right here. I have to check if I'm done. If there's a minus and it's a perfect square, so perfect square and subtraction, make a little note for yourself, then you can factor further. If there's a plus sign here, you cannot, okay? And I'll show you, there will be examples. So since 3 times 3 is 9, those are my factors. And x plus 4. And then we just do the split and solve. Split and solve. And you just do x plus 3 equals 0, and you have to show this step. You cannot skip it. I know it seems silly, but you're going to see why in the next one, why it's not silly. And so x equals negative 3, x equals positive 3, x equals negative 4, and we check it out. Negative 4, yes. Negative 3, yes. Positive 3, yes. The order does not matter. Okay, so that's how we use factor by grouping in order to find the roots of a polynomial function. The last one we're going to look at before we go over one other thing is going to be this example here, okay? And in this example here, just going to slide that down a little bit so we can see it better. Okay. We have to do the factor by grouping again. So I replace y with 0. I'm going to underline my groups, okay? And what can divide out of both of these? I can divide 3 into both, and they both have a common x. So I'm going to put 3x outside the parenthesis. I divide 3x squared by 3x, and I'm left 3x to the third by 3x. So that's going to be x squared. And I put that in my calculator. Negative 45 divided by 3 is negative 15. And the x's here would cancel. I have a negative sign, so I put a negative sign. And 4 goes into both of those, but there's no common x, so I can't put an x here. I'm left with x squared. 60 divided by negative 4, use my calculator. And negative 15, that's great because same, 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 same. Okay, so now I've got 0 equals 3x minus 4, because those are each on the outside, and then x squared minus 15. All right, split and solve. So I write 3x minus 4 equals 0. I write x squared minus 15 equals 0. Pay attention right now. This is the one that's new and different, and so I want to make sure you understand this. Okay, so here, I want to get rid of a minus 4, so I add 4 to both sides. You're just solving it like a regular equation. 3x equals 4, and then I divide by 3. X equals 4 over 3. If I look at my roots here, I notice all of my roots are not whole numbers. That's why this one is going to be slightly more difficult, okay? So this is 4 over 3 is one of them. Okay, that's a little over 1. That's this guy right here. And here, it's not a perfect square, 15. That's why I couldn't factor more. So I'm going to add 15 to both sides. You have x squared equals 15. Who remembers the opposite of square? You were right, square root. So whatever I do to one side, I got to do to the other. The square root and square cancels out. But this is the trick, and everybody make a big note for yourself. Write this really large. You have a plus and a minus in front of a square root. So whenever you do square root on both sides, it can be positive or negative. Because the square root of 9 is 3, and the square root of 9 is also negative 3. So that's why it's the plus or minus. So x is equal to the positive or negative of square root of 15. On Delta Math, you're going to see a button that looks like this. You're going to use that button, okay? And you're going to see a square root button underneath the answer. So when you get an answer like that, you can use that. All right. So now we're going to go over how do we actually simplify radicals like that. So if we have a square root 15 and I want to simplify it, how do I do that? So you may remember this or this may be new. First thing is in your notebook, write down a perfect square list, okay, and make it nice and big, highlight it so that it stands out in your notes. You're going to refer to this a lot. What you want to do is you take the number inside the radical. That's called the radicand, okay? So this number is called the radicand. And you want to see what's the biggest perfect square that divides into 216. So you know it's going to start somewhere down here. So 216, can't be divided by that, but I'm going to start around here and just start dividing. So you have to use a calculator. 216 divided by 144, doesn't work, gives me a decimal. Try 216 divided by 121. So each time I'm just doing 216 divided by this number. Okay, 216 divided by 144 doesn't work. 121 doesn't work, 100 doesn't work. These are all giving me decimals. Let me try 216 divided by 64. No. 49 doesn't work. Let's try 216 divided by 36, and that works. So 36 is the golden number. So I break this down into two perfect squares. This is how you're going to write it. The perfect square, two radicals. The perfect square goes first. So the number that you got from here goes here. It has to be a perfect square always. That's really important. When I divided 216 by 36, I got 6. So I got that by doing 216 divided by 36 equals 6. Okay? Then the square root of 36 is 6, and you just bring this one down. 6 radical 6. And that's how you do it. We'll do one more really quick one. Let's do... Okay, square root of 405. 405. Okay. So again, I'm going to start at the bottom. You should have all of these memorized up to 225. So I start dividing my way up, and these big numbers, they don't work. I'm trying them. I know 100's not going to work. Let me try 81. I do 405 divided by 81 in my calculator, and it works. So the first number is my perfect square, and that's 81. And the second number is 5, because 81 times 5 is 405. Square root of 81 is 9. You just bring this down. So that's how you simplify. Now we're going to go to the quadratic formula with simplifying radicals. So you may remember this from last year. I hope that you made a song maybe. Okay, I know a lot of students do songs to remember the quadratic formula. That's a great way to remember it. Hi. Okay, so feel free to pause this. You're going to write a lot of notes. So solving quadratics with the quadratic formula. Here's my equation. The first thing, remember that in these cases it was always equal to 0 because that's where it lands, the roots are, on the x-axis where y is 0. So the first thing I need to do is get it equal to 0. So to do that, I would minus 6x on both sides. And it has to be in standard form, so the correct order would be 3x squared. The minus 6x would go next, and the plus 2 would go after. And then 6x minus 6x is 0. So that's how you know you're good, if you have it equal to 0 right here. Okay, that's what's important. So now, next thing we're going to do is we label the a, b, and c. So ax squared plus bx plus c equals 0, okay, or equals y. So the a is always the number in front of the x squared. So I'm going to have a is equal to 3. Make sure to pay attention to the sign. B is the number in front of the x, negative 6, and c is the constant, no variable, c equals 2. And now we're going to plug it into this quadratic formula, okay? So make sure that you are taking good notes. Pause it at any point. When you plug into the quadratic formula, you don't have to do anything fancy. You're just plugging in. So it starts with x equals negative, always parentheses. So what's my b? Negative 6. Plus or minus the square root. Parentheses everywhere that I'm plugging in a number. Minus 4, parenthesis a, parenthesis c. You're going to see a video in here that is optional, but it's funny and it'll help you remember this. So I recommend you watch it. And then 2a, plug that in. So just to highlight what we just did, okay, So A was equal to 3. So everywhere that I had A, which is right there, I plugged in my 3. B was equal to -6. So everywhere that I put B, notice the negative is outside. Okay, so the negative is outside there. You put that. And then C was equal to 2. And that's just right here. And so I just plug that in right there. Feel free to get some color-coded pens and color code this. Okay, now we're going to use our calculator. So just take your calculator and plug this in without the square root in your calculator. So you're just typing in parenthesis, -6, close parenthesis, squared, -4, parenthesis 3, parenthesis 2, close parenthesis, enter. Bring everything down. Negative times a negative becomes a positive. So it's x equals +6 plus or minus, because remember that when you factor, there's 2 roots. I just did that in my calculator and I got 12. And 2 times 3 is 6. Now, square root of 12 is not a perfect square, so I can't take the square root of it. It gives me a decimal. However, I can simplify it. So I want to simplify my radical if I can. Okay, and so the way that we're going to do that is we're going to take my square root 12 and I'm going to say which perfect square divides in. It's got to be one of these small ones. So 9 doesn't work, but 4 does work. So I divide it by 4. Okay. And it's square root 4, square root 3. The square root of 4 is 2, so it's 2 radical 3. My final answer, so that's the radical 12, just simplified, is x equals 6 plus or minus 2 radical 3 over 6. I'm going to show you how to type that in to Delta Math. Okay. So you're going to write, what was it? 6 plus or minus 2 radical 3 over 6. So it's a fraction, so I put the division first. I want to see my whole keyboard. Okay, so I'm going to put division first, so it's a fraction. And it was 6, yeah, 6 plus or minus, okay. So I put 6, I put the plus or minus button, 2, the radical button, 3, over 6. Oh wait, it can be simplified. I didn't notice that. What number can divide into all of my coefficients? You can divide them all by 2 to simplify it more. We always want to simplify things as much as possible. So whatever you do to the top, you do to the bottom. This would be 3. This would cancel out, and this would be 3. So here, that would be 3. That would be nothing, and that would be 3. Just to make it as simple as possible. That's how you're going to type things in. So I just wanted to show you that. There is practice. This is review, but it may be new for you. So have fun, ask questions. I'm around over break. Where am I going to go? It's COVID. Send me an email if you need help. I can even Zoom with you if you want to do it. Maybe I'll do like one tutoring session over break. So if you want to do this together, feel free to do it over the weekend if you want to get it done before your break. Up to you. Have fun, and I'll see you guys later.